In Python, types are determined automatically at runtime, not in the response of declaration of your code. Okay, you never declare a variable ahead of time. This we discussed just now. So what actually it is? It means, so in Python we have couple of steps. We create a variable, and variable is created when your code first assign it a value. Future assignment changes the value of already created name. Okay, Python detects some names before your code runs, but you can think of it as through initial assignment. Here you will see names is used, means it is notating saying that some names, detect some names. It future assignment changes the value of already created names. Yeah. uh, uh, am I audible now? Am I audible now? Okay. 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 So what I was saying is, yeah, in Python, uh, actually variables are not like as in C++, Java. Whatever we write, like A, B, whatever we write like this, right? These are just names. These are not actually a variable which have some memory. These A, B, C, whatever variable name we give, these are just a name. They don't have any memory. And because they don't have any memory, we cannot declare them. Okay. In C++, or any other language, Java, when we declare a variable, at that time that variable gets some memory. In Python, it is not like that. In Python, uh, you get a memory when you initialize it, and we'll see what it means. Variable types. A variable never has any type information or constraint associated with it. So whatever name you are giving, it will not have any type information. Okay. The notation of type lives with objects, not names. This is the reason why you cannot we can say that Python is a dynamic memory and dynamically typed language. Variables are generic in nature. They always simply refer to particular object in a particular point of time. When a variable appears in an expression, it is immediately replaced with the object that it currently refers to. All variables must be explicitly assigned before they can be used. Referring unsigned variables errors result in errors. So is this clear, or I think it should confuse you, right? Because till now we think that variable has a memory, but in Python it is not. In Python, objects has contains some memory. Okay, so let's see if when you write a equals to 3, what happens? It do three things. Create an object that represent the value 3. Okay, create the variable if it does not exist. Link the variable a to the object 3. So when we write a equals to 3, at that time 3 will get the memory. 3 is the object which will get a memory. Okay, and a is a name which will refer to this memory. A itself will not have any memory. A will refer to this memory. It will refer to this object. Okay. Variables and objects are stored in different part of memory and are associated by links. Means they will Means links you can think as a pointers in other languages. In C++ or C, you can think it as a pointers. Okay, always links to object and never to other variables. Means A will never refer to B. If you have some B equals to 4 or B equals to 3, so A will never refer to B. Okay, A will always refer to this object 3, because 3 will have memory, B will never have memory. Large objects may link to other objects. What this means is, when we have a list or tuple or anything, so those may refer to other objects. Means if we have a list, I will go in detail what list is. Just for example, I will show you here. When we are creating a list like this, so in this step, these 1 2 3 4, they will get a memory. Okay, and this list object, this will point to those memories. Got it?
Okay. Okay. Mhm.
Okay. Okay.
Dheeraj, here
Mhm.
I have a confused. Uh,
Yes. So, means variable is means it's not a typical variable which we use in other C, C++, and Java. Okay. This is the difference between Python and these languages. When we create a variable in these languages, at that time, that variable, suppose we wrote int int a equals to 10. Okay.
Mhm.
What happens in this int a? This a will get some memory in somewhere, and that memory will contain 10.
Okay. Mhm.
Okay, so now this a will have a fixed data type, integer. A cannot refer to any other type of value. Means a cannot have a string value or float value,
Mhm. Mhm.
right? This happens in C++. But here,
I think it is similar to reference, right?
uh, reference you can relate, but reference are also different, because references in those in C++ is also very statically binded with the type. Here these are not type fixed. Means these, you can think it like you have a memory, this
Mhm.
object, and you are naming this object with the different names.
Okay. Okay.
Okay.
Then in that case, we don't have a variable concept itself. That's it.
Yes, ideally speaking, there is no variable, typical variable concept here. It is a name. It is actually a name. Okay.
Okay.
But variable is used because this term is very common in programming languages to notate anything, that it is a variable.
Mhm.
It is a very common thing. That's why. But actually, it's not a variable. It's a name. And because of that, when we write t equals to 3, okay, and in the next line itself we can write this string. This is working because a is just a name. This a do not have any memory. It don't have any type. Okay, this is
Mhm.
just a name.
Okay.
So
Okay.
what we did here is, in these two lines is, in first line we created one memory for 3. Okay, and
Mhm.
we named a, and a is referring to 3 now, right now, in this line. Okay, in
Yeah.
the next line what we did, we created another memory, test.
Mhm.
Okay, it will have a string type. So that object
Mm-hmm.
this will have these types and all these information. Now we
Mm-hmm.
change the meaning of a to this, means now a is pointing to this memory,
Okay.
because a itself do not have any memory, a itself do not contains any type, a
Mm-hmm.
do not have any type. So that's why we can do this. But in other languages, in C++, a contains a memory and a has a type. That's why there
Okay.
we cannot do this. Got it? Yeah. So these links you can means in Python we refer it as a reference. We say it as a reference. Okay, but don't mix this reference with the C++ reference. Okay.
Okay.
Yeah. So a reference is a kind of association implemented as a pointer in memory. Okay.
I did not get reference
Means
kind of association.
yeah, means it's a association between name and object.
Mm,
Okay. It's means as a pointer in memory means it's just kind of a pointer, it will point to this memory.
okay.
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 Yes. uh, this name, yeah, obviously somewhere this name is going to be stored, so that is in stack these names goes, means that memory mapping is there. Python do one memory mapping, which maybe I will go in detail in some other session, because it itself has a lots of things. So for now, I will just tell you these names. These goes into stack memory. Okay, and these objects which we create here, these goes into heap memory. Okay, whatever objects we are creating, though that goes into heap, and these names we store in stack. Got it? And now from stack it will point to that memory. It will very much look similar, like it will be like dynamically allocate memory allocation in C or C++. It will means it will give you a feel of that, that you have a pointer here in, means in C++ you have a pointer in your stack, and then it points to some heap memory, right? It's something similar kind of thing. So these names goes on stack. Okay. Yeah. So just we'll consolidate these things. Is variables are entries in system table with a space to link to the objects. Okay. Objects are piece of allocated memory with enough space to represent the value for which they stand. Okay. What it means is objects which are getting memory, it will store two things. One is type and one is reference count, which we'll see what reference count is. So object stores the type of the data. What is the type of the data? Okay, that's why we can do a equals to 3 and then a equals to test, because of this thing, because a do not have any value, b object has that data type, what type it is. References are automatically followed pointer from variable to objects. So this is how means when you write a value, write a variable in an expression. So through this reference, Python get to know, okay, this is the object to which this name is referring, so it will replace that value into that expression. Clear?
Yeah.
Yeah.
Yeah. Yeah.
Okay. So the very means it's a very good thing what Python do is internally it caches and reuse certain kind of unchangeable objects. Okay, we'll see what this means somewhere means Python do internally some caching for the objects so that they don't get created again and again. Okay, so each object also has means two standard headers, which I said, type designator used to mark the type of the object, and a reference counter used to determine whether it's okay to reclaim the object. Okay, so this is the example which I showed you, that name has no type, type lives with object, and again the same thing, we have simply changed a to reference different object. Because variable have no type, we haven't changed the type of the variable a, we have simply made the variable reference to different type of object. Okay, objects on the other hand know what type they are. Each object contains a header field that tags the type. So this reference counter we introduced means, till now is it clear about the type, how Python identify the type? Okay, so we introduce this reference counter. So each object, it has some reference it has one reference counter which increments when we refer to that. Okay, what it means is, like we have a equals to 3. Okay, now we are writing b equals to 3. So what happens in these two lines is, yeah, sorry, this a is not pointing to this 3 right now. So okay, we'll go through, like b equals to 3 and now c equals to 3. Okay, what will happen is, now in memory 3 will have some 3 will have some memory somewhere in RAM or somewhere, right? So in this line b is pointing to 3. So 3, it will have a reference counter with associated with this, which will be 1 in this line, because b is referring to 3. So this 3 will have this count, means how many people, how many names are referring to me. This 3 will have that counter. So in next line when we write c equals to 3, in this case count this reference count of 3 will increment by 1, because one more name is referring to me, so it will increment its count. So by the end of this line, uh, 3 will have reference count 2. Okay, because 2 names are referring to 3, to this object.
Is there any command by which we can get like how many references are there?
Yes, we have in Python, we have one module. Sys- What is that module name? Oh, okay. In this, there is one function, get rep count. If we pass it 3, no, You will see. It has reference count 31. So why it has reference count 31? Because this is when we call this get reference ref count. At that time, this get reference count ref count will means it will, this 3 will be passed to it some temporary. So this will also refer to 3. That's why this one is. Otherwise, 30 is the reference count. Means in memory, 3 means there is one object 3, and there are 30 other variables names which are referring to this object. Got it? And this object will be in memory. It will not be destroyed till this reference count goes to 0.
Okay, so
Okay, but
so
how
this,
to make it zero? How to make it zero?
uh, how to when you are creating any object, okay,
Mm-hmm.
and when it goes out of scope,
Mm-hmm.
okay, at that time
Mm-hmm.
this
Yeah,
reference count get decreased. Okay, suppose in an scope you created one memory one name a equals to 3, so 3 will have some memory. Okay, now a is going out of scope, so reference count will become 0, right?
mm-hmm.
So at that time, in that situation, this memory will be released. How? Means garbage collector keeps checking about this, that when the reference count goes to 0, garbage collector remove this memory. Or when you can use this function, del function. So we have c. Okay, okay, we del c. Now if we'll do this, let's see, it its count decreased. Got it? So what this del function do is it only decrease the reference count of this object, this 3. It will not release the memory. Memory will be released through garbage collector. Okay.
yeah, and that will be done only when the reference becomes zero.
Yes. When reference count becomes 0, at that time garbage collector will clean that memory. Okay. So there are different algorithms garbage collector contains. Means this reference count is in C Python. When if you will use Jython or any other Python, so the way garbage collector work, that may differ. Okay, but in C Python, it works as a reference counter. It works on a reference counter, because in Java, I think there is some scheduling something kind of thing, that at a specific time it will check. Sorry, mark. It's a mark and delete kind of thing. Algorithm is used in Java, right? So it will mark all the first. It will mark all the objects which need to be released, and then it will clean. So it happens in Java. So if you will use JPythons, you will find that kind of garbage collection there. In C Python, reference counter is used. What the benefit of this reference counter is, uh, means whenever a reference count goes to 0, this memory will be released. Okay, as soon as no name is referring to this memory will be released. And at the same time, it has one some drawback, like it impacts on the performance, because every time, means very often, this garbage collector comes and it clears the memory. Okay, but it has more advantage than this. than disadvantage. So that's why I think they are preferring this. Clear till this point?
Yeah.
Yeah, Dheeraj.
Okay. Okay. So next point is shared reference. So which what we talked. If we did a equals to 3 and then b equals to a, what will happen is a and b both will refer to the same memory. Okay. Same object. Both will refer to the same object. Okay. Uh, I can show you that all. So it will make more clarity. Okay. If we have a equals to 3, okay, and we have b equals to a. Now in Python we have one function id. What this id function do is it gives you the address of the object. Okay. So this 3 in this line we created a equals to 3. So now a is pointing to this address. Okay. 3 has 3 the address, the memory address of 3 is this. If I write same for if id b, it will give you the same address. Got it? Means a and b both are referring to the same memory. Now suppose if I write a equals to 4, what will happen is now a is pointing to some different memory. See. Okay. Clear? So means this will demonstrate that these names are referring to memory. Okay. So this is what is explained here. This scenario in Python with multiple names referring to same object is usually called shared reference or shared object. And if you are changing the values, okay, if you change the value of a to some other type or anything other than 3, it will start pointing to some new memory. So when you write this line, okay, at that time spam will get a memory, okay, and it will start pointing to this. Okay. And suppose if you write like this, a equals to 2 or something, so we again, so now a is again pointing to the same memory. Okay. Now we'll do a equals to a plus 2. Now address is changed because the value this expression calculated is different than what a was earlier referring. Okay. So now a has 5, so 5 got a new memory. Okay. So means you it so the values will not change, means this value will not get changed in place in this integer and all these kind of things. Values means if the new value is coming, it will gets value means memory somewhere else, a new memory it will get. Okay. Now shared references are in place changes. So if you have any mutable type means list, dictionary, or sets, anything like this, so in which you can change a value. Okay. So there you, if you will change, say if we have a list 1, 2, 3, okay, and there's another list pointing to same, so L2 is also this. Now I'm doing L1 0 equals to 18. Now L1 is this and L2 also got changed. Okay, so this object means these two objects are sharing the same memory location. Okay, but the memory means L0 was referring to something. For example, if I try to get ID of L0, sorry, L10, this is the address, right? Now if I change this to 20, now the address changed. Okay, so this L1, because this is a list, so there will be one object which will have this list, and this object is referring to some other objects 18, 2 and 3. So what we did here is we changed this 18 to 20, right? So 20 will get some new memory, and this L0, this will start pointing to that new memory. Got it? So this is what shared references means. If you are sharing, so values will change like this, but the basic concept of object memory allocation, that is same, means each new value will get a new memory. Okay, so if you want to check, I means one thing I showed you that to check the address whether A and B are pointing to the same address or not, one way was of doing is was this. You check like this, and other you can do is A is B. This operator compares the addresses of the two objects. When you write A equals to B, this will compare values. Why it is false? Because we changed this A here. That's why it is false. But if I do A equals to 3 again and I run this, this will be true. Okay. So this equals to will compare values, and when you will do A is B, in that case it will compare address. Okay.
No, so when we
Yes.
compare the object,
Yes.
and when we say A is B,
Check the address.
what is returned by the ID, right?
Yes.
Okay.
Okay. And next thing is when we say x is equal to 42. Okay, I told you that when you are referring to any variable, say a equals to 50, when you are referring to any variable, okay, so in this case 50 will get some memory, right? Now if you did a equals to 30, okay, So reference count of 50 should be decreased. And because we do not have any other name pointing to this 50, this should be released, right? As per our theory. But what Python do is Python do some caching kind of thing. Get ref. Okay. Why it is? Oh, sorry. EF. Thanks. Okay. So we created this uh, and we changed this value to this name to point something else, but still its reference count is 7. Okay. Because some means for now maybe some other names are referring to this, but Python also contains caches these small integers, so that if some other name comes in picture and it wants to point to that to this value, so it will not create any new memory. It has in cache, and that new variable will start pointing to that. Okay. So this is a small caching too. But if it is a large object, obviously as soon as reference count goes to 0, it will delete. But for small integers, it or small strings which are frequently used, it caches those things. Just let me see. Yes. So directly we can use this also on that value. So we can check where it is stored. Okay. So this is what the memory, how variables are stored in memory, and how Python handles this memory management. And this is the reason why it is called dynamically typed, because any any variable name can point to any data type. And why it can point to any data type? Because variable name don't contain any type or any memory. The type and memory is associated with the object, with the value. Okay, not with the name. Okay. Okay. Yeah. So this was this is all for this session.